Hello and welcome to Math Matters. I'm Mrs. Halpin, and today we're going to continue exploring equivalent fractions, decimals, and percentages. This content might be review for you, and that's okay. We're strengthening our understanding of rational numbers to prepare us for circle graphs in the next lesson. For this lesson, you will need paper and a pencil or something else to write with. We'll pause for a moment while you gather those materials. Now that you're ready, let's get started. There are a couple of learning goals for today's lesson. We'll have one math goal and one portrait of a graduate goal. Let's take a look at today's math goal first. I am learning to identify equivalent relationships among fractions, decimals, and percents. Now let's take a look at our portrait of a graduate goal. Our portrait of a graduate goal is focused on being a creative and critical thinker. Our goal for today is, I can revise and refine my ideas. Mathematicians are always learners. They might change their original thinking after they've seen another strategy or heard it explained a different way from a friend. Your perspectives and ideas might shift, and that's a good thing. Today, I encourage you to be reflective in your thinking. I will try to provide opportunities to revise or refine your ideas throughout the lesson. Which one doesn't belong? For this routine, select one image that you feel doesn't belong. Why do you feel it doesn't belong? If you have more time, select another image and come up with a different reason it doesn't belong. Take a moment to jot down your ideas. Maybe you thought image A doesn't belong because its value is 4/100ths, which is less than the other images, or that it's the only number shown on a hundredths grid. Or maybe you thought image B doesn't belong because the image encourages you to represent the value as a fraction. You might have named this value as 2/5. You might have thought image C doesn't belong because it's the only number line. Image C has a value of 4/10ths or 40/100ths. I'm noticing this is also equivalent to 2/5 from image B. Lastly, maybe you decided that image D doesn't belong because it's the only image represented as a percent. I'm thinking to myself, 40%, 4/10ths, and 2/5 are all equivalent. 4/100ths is the only image with a different value. These are just some reasons each of these numbers may not belong. You may have thought about a different idea or different reasons, and that's okay. Your ideas can be different. There is no right answer because there are so many ways you could think about this routine. Let's read about Fox Chase Farm. Fox Chase Farm grows flowers. The picture shows how many acres of each type of flower they planted. What do you notice? What do you wonder? You might have noticed that the farm is split into 100 acres. So 1 acre would represent 1/100th of the farm. You might have noticed that more than half of the farm is planted with red flowers. Maybe you noticed that the trees and purple flowers represent the smallest fractions of the farm. You might be wondering, why are there more red flowers than any other type of flower? Do they sell these flowers? And if so, do a lot of customers request red flowers? You might be wondering, why are trees included in this flower farm? There's a lot of questions you could ask the farm about why they designed their farm this way. Let's see how fractions, decimals, and percentages relate to this situation. Mathematicians look for connections, and we're going to connect Fox Chase Flower Farm to what we know about fractions, decimals, and percents. I encourage you to write down the fraction, decimal, and percent representations for each section of the flower farm. You may want to record this in a table to keep track of your thinking as we go along. We'll pause while you write down the chart. All right, so let's start with the red flowers. What portion of the farm is planted with red flowers? If I count each hundredth, I can see that 60 hundredths of the farm is planted with red flowers. I can represent this as 60 over 100 or 0.60 hundredths. Since I know percent is out of 100, I can say 60% of the farm is planted with red flowers. Now I'm going to give you a chance to think about the orange flowers. How could I represent the orange flowers as a fraction, decimal, and percent? I'll give you a little bit of time to record your thinking in your table. I can see 24 squares or 24 hundredths of the plant farm is shaded in. I could name this as 24 over 100, 0.24, or 24%. Pause for a moment to reflect on your thinking. Critical thinkers revise and refine their ideas as they go. Do you want to revise or refine your ideas about how to find the fraction, decimal, or percent before moving on to the next row? I'll give you a little bit of time to think about that. Take a moment to think about the purple and green flowers. How could I represent those sections as a fraction, decimal, and percent? Record your thinking in your table. I noticed that the purple flower section is really small. The purple flowers are planted on only 9 acres out of 100 acres of land. The purple flower represents 9 over 100, or 0.09 hundredths of the flower farm. Both of these values are equivalent to 9%. Lastly, we can determine how to represent the amount of trees as a fraction, decimal, and percent. I can visually see that this is the smallest section of the flower farm. I only planted 7 acres of trees. 7 out of 100 can be written as 7 over 100, or 7 hundredths, 0.07, or 7%. If we named each portion of the farm correctly, we would use all 100 acres of land. Let's find the sum of our fractions to make sure the sum adds to exactly one whole. If it does, we know we have correctly named all of the parts. I notice that all of these fractions have 100 in the denominator, so if it adds to 100 100ths, I've accounted for the entire plant farm. So I can add 60 plus 24 plus 9 plus 7, and I can see that my sum would be 100 hundredths. I can also add the decimals. Sometimes I like to think about decimals as money. So if I add 60 cents plus 24 cents plus 7 cents plus 9 cents, it adds up to 100 cents or $1. Lastly, I know if I used all 100 acres, I would have planted 100% of flowers on 100% of the farm. So all of my percentages should have a sum of 100%. 60% plus 24% plus 9% plus 7% will give me a sum of 100%. I can check my thinking with the picture and see that I've accounted for all 100 acres of the flower farm. Let's take a look at figure A and figure B on your screen. What is the same? What is different? Let's think about what is the same first. You might have noticed that the whole for each figure is approximately the same size, or that both figures have the same amount shaded. Both figure A and figure B represent the same value. Now let's think about what's different. You might have noticed that the colors used to shade in figure A and figure B are different. You might notice that figure A is cut into smaller pieces than figure B. Figure A is split into thousandths. Mathematicians call each tiny piece 1,000th because it takes 1,000 of them to make a whole. Figure B is split into hundredths because it takes 100 of those pieces to make a whole. I want to give you a moment to reflect on your thinking. Did you hear anything new that you didn't originally think of? Do you want to revise or refine your thinking at all? We'll give you a little bit of time to think about that. We know that the value of figure A and figure B are equivalent. Let's explore the different ways mathematicians can name this value. Let's take a look at figure A. We know that this grid is split into 1,000 tiny little pieces, and that each piece represents 1,000th. I could also look at this grid and see 100th, or if the grid was broken into 100 pieces. Inside of each 100th, I can see that it's broken into 10,000ths. So I could name that amount as 10,000ths or 1/100th. How can I use this information to help me name this amount? Well, one way I could figure it out is that I could count how many thousandths pieces are shaded in. That might take me a really long time. It looks like there are a lot of thousandths on that grid that are shaded in. I could use what I know about equivalent relationships. I know that 1/100th is the same as 10 thousandths. So if I have 32 hundredths, that would be the same as 320 thousandths. So now I've accounted for all of the full yellow boxes shaded in, and I can name that amount as 320 thousandths. I can't forget about the leftovers I haven't counted yet. I see that there aren't enough thousandths to make another hundredth. It looks like half of the hundredth square is shaded in. Again, I know that each hundredth square is equivalent to 10 thousandths, so half of that would be 5 thousandths. That means that I have 325 thousandths altogether. I can write this number as 325 over 1,000. This is how I would name it as a fraction. Let's look at figure B to help us name this figure as a decimal. Let's take a look at figure B. I can see that 3 green columns are shaded in. Each column is called 1/10 because it takes 10 of them to make a whole. So one column represents 1/10. And since there are 3 green columns, that represents 3/10. The blue piece represents hundredths because it takes 100 of them to make a whole. I can name these 2 blue pieces as 2 hundredths. Lastly, I can see that there is a very small orange piece. It looks like half of 1/100th. Since it takes 10 thousandths to make 1/100th, half of 100th would be named 5 thousandths. To name this number as a decimal, I can write a 3 in the tenths place to represent 3/10ths, a 2 in the hundredths place to represent 2 hundredths, and a 5 in the thousandths place to represent 5 thousandths, or that very small orange amount. Whether I write this number as a fraction or a decimal, I say it the same way, 325 thousandths. So now that we know how to name this number as a fraction and a decimal, how could we name it as a percent? We know that percent means per 100. We can divide 325 thousandths by 10 tenths to get 32.5 over 100. Let's think about why this works. I'm dividing the numerator and denominator by the same number. I know that 10 tenths is the same as 1 whole. And when I divide any number by 1 whole, the value doesn't change. For example, if I did 7 divided by 1, my value, the answer would still be 7. So when I divide 325 thousandths by 10 tenths or 1 whole, I've created an equivalent fraction. The value has not changed. So now I see that 32.5 over 100 would be the same as 32.5% or 32.5%. Let's take a look at another model. In this model, we can see 32 hundredths shaded in. We know that 32 hundredths is equivalent to the 32%. This is shown in blue. And then we have a half of a percent shaded in, shown in orange. The orange part represents 1/2 or 5/10ths of a percent. If I had an entire percent, one entire box would be shaded in orange, but I don't. Only half of it is shaded in. So when I combine my 32% and half of a percent, I can name this value as 32.5 or 32.5%. Let's revisit our math goals for today. I am learning to identify equivalent relationships among fractions, decimals, and percents. What is something you learned today? What is something you might be wondering? I encourage you to share what you learned or what you're wondering with a family member or a teacher. Our portrait of a graduate goal was to revise and refine your ideas. Were there any moments where you revised or refined your thinking today? If so, how did it help you as a creative and critical thinker? Thank you for joining me on today's episode of Math Matters. I'm Mrs. Halpin. I hope you have a great day and keep on counting.